Okay, good morning to everyone. Okay, so I welcome you all for this wonderful session on smart applications of Internet of Things based on MQTT and Thinkspeak Cloud. Okay, so it was organized by the Department of BCA, Hindustan College of Arts and Science Engineering Colleges, in association with NoviTech. First of all, I would like to thank the coordinators, Dr. P. Lalita Madam, Professor BCA Department, and Mrs. P. Jayashree Madam, and the convener Dr. P. Sendil Vadivu Madam, Professor and Head of the Department. Okay, is it audible to all of you? Is it audible to all of you? Can I get a quick confirmation? Okay, thank you. Okay, so let's enter the topic. So I'm Karthik, project engineer and NoviTech R&D Pvt Ltd. Okay, so before we enter the topic, I would like to introduce ourselves. So we are NoviTech. So NoviTech is a technology company specialized in product engineering with main focus to industries, automotive and robotics and industrial electronics. And we are doing a academic project training for both engineering and arts college students in some variety of domains and variety of applications like artificial intelligence and Internet of Things and OpenCV image processing and Java and power electronics and power systems and etc. So and we are conducting a lot of faculty development programs in some reputed engineering colleges in Kerala and Tamil Nadu also. Okay, and we are doing a hands-on workshops and in-plant trainings and internships. So our main office in Ramnagar, Coimbatore, and our another one branch located in Kalur, Kochi. Okay. So this is our today's agenda. So in this session, so we are going to see about the introduction of Internet of Things. So what is the introduction? What is the Internet of Things, and what are the process inside of the Internet of Things? And then processes of IoT, and then introduction about Raspberry Pi and Python. So Raspberry Pi is a microprocessor that we are using for this course, and then how to interface the sensors with Raspberry Pi using the Python programming, and then upload the sensors data into the MQTT and Thinkspeak cloud. Okay, so this is our today's agenda. So and guys, if you are new to this channel, kindly subscribe us and click a bell icon for get notifications about our upcoming videos. Okay, so first initially, I would like to explain about this application. So consider, so this is one of the refrigerator. Okay, so we all know about it, refrigerator. And nowadays the more number of smart refrigerators are available in the market. Okay, so see, so first initially, so these types of refrigerators have some display in a door, and it inside of it has some sensors. Okay, so for example, here we add another one sensor like a camera. Okay, so if we add the camera and if we apply the some OpenCV image processing concept into the refrigerator, so it will identify the products. Okay, so eggs and some milk and some vegetables and fruits, so it will automatically identify it. Okay, so and after applying the sensor, so it will automatically identify the objects. Okay, so automatically identify the things that we are inside of a refrigerator. Okay, and then if you are at the internet of things, if you are at the internet to the normal refrigerator, then it will be converted into the smart refrigerator. Okay, so and after that, so we can get a notification, so we can get a details about the products inside of a refrigerator. Okay, so in our mobile phone, so that is the connectivity and technology. Okay, and after that, if you are at some another one technology called data analytics and or machine learning, um, so means we can converted this smart refrigerator into the some ultra smart refrigerator. Okay, so for example, so first initially we need to train the machines using by the machine learning algorithms. Okay, so because machine learning means we need to teach the machine. Okay, so it's like so here we need to give us some data. So data means the data set. Okay, so that data sets contains some previous usage history of our products in refrigerator. Okay, and after we need to train this data set into the machine, and then our input data. Okay, so after giving a some data set to the machines, we need to give a input data. Okay, so comparing with these details, so and using by the some algorithm, so we can get a food recipes list. For example, first initially, so these details is given by the refrigerator camera, so through the internet of things. Okay, so we can get these details. Okay, and these are the some shopping list. So what the things we are need to buy in a shopping market. Okay, so we can easily identify that from the internet of things. Okay, and after updating the machine learning to the machine, okay, so we can get a food recipes, so based on our available things. Okay, so basically in this system we need a three parts. First one is the sensor, so for capture the data for sensing the some things and objects. And after that we need a internet of things, internet connectivity for sharing the data from one place to another place. And after that, some machine learning algorithms. Okay, so this three thing is very important for every smart applications. Okay, so in the sessions, so we are doing that process. Okay, so I'll give a introductions about internet of things. So internet of things, it means that internet for things, so we need to connect to the internet for everything. So it means so taking all the things in a world and connecting them to the internet. So this is the thing. So we can connect the internet to any things, so that's called internet of things. For example, if you take your table or chair and door, so we can connect this all the things into the internet. That's called internet of things. So we need to connect all the things in the world into the internet and let them communications. Okay, so this is the process of internet of things, the main definition of internet of things. Okay, so for this process, for connecting a normal things into the internet, we need some things. Okay, so that is sensors for read the data and actuator for give the data. Okay, so he is the inventor of Internet of Things, Kevin Ashton. So he was done this Internet of Things at 1999 using by the RFID technology. Okay, so RFID means it's a radio frequency identifier. Using by the RFID technology, they get us some data, some informations from products, and they will update these data into the cloud. Okay, so this is the first thing ever, first thing of Internet of Things, and he was created this Internet of Things at a Auto ID center in MIT. Okay, and see the processes of Internet of Things. What are the processes we need for applying the Internet of Things, for getting an Internet of Things? The main process, as I'm told already, data collection. So data collection, and then communication, and then analyzing and acting. So I'll give a short introductions, short definitions. Data collections means we need to collect the data from our environment. Okay, so this is the data collection process. And then communications means the simple things. We need to transfer the data. So transfer the data from one place to another place, that's called the communications. And then analyzing. So analyzing, it's a checking process. We need to analyze all the data and we need to get us some report from that analyzing part. Okay, so this is the third part. And then acting is a final part, final process. So based on that analyzing report, we need to take a action. Okay, so this four process is very important for the Internet of Things and every process: data collection and data communication and data analyzing and that acting. Okay, so let's see the one by one. So data collection. So simple already, for this process we need some sensors. Okay, so sensors means it's nothing, it's a sensing device. Okay, so it senses the environment. For example, if you were take our mobile phone, that also has some lot of sensors. It has a proximity sensor, and it has some accelerometer sensor, and MEMS sensor, and gyroscope sensor, and mic and camera and fingerprint sensor. There is a lot of sensors are available in our mobile phone. Okay, so we can identify our mobile tiltation using by the gyroscope sensor. Okay, so the every sensor is using to convert the physical signals into the electrical signals. Okay, so first see, so here we're using the temperature sensor. Okay, the basic temperature sensor, that is thermistor. Okay, so reading the temperatures data from environment, so from the physical signals. So this temperature sensor is used to convert this physical temperatures signal into the electrical signal. Okay, so that is the main reason and main purpose of sensors. So collecting the information from environment and convert this physical signals into the electrical signals. So that's called sensors. Okay, so for this process definitely we need some microprocessor or microcontroller. Okay, for example, if you were take our body, means a human body, so they have some lot of organs. Okay, so and our eyes and our ears and our tongues and our skin is all are the sensing parts. Okay, so this type of parts is using to sense the environment and getting a data from surrounding. Okay, so these types of organs, that basic 5 senses. Okay, so and next we need to send this data into our brain. The brain is our main part, as like here we need a processor as a main part. Okay, so using by this sensing data, we need to analyze it and we need to take a one action. For example, if you want to switch on your fan, means you need to first initially you need to identify the switchboard, and next you need to send this command into our brain, and after that brain analyzing this data, that location, that place, and next it's create one command for our hands and legs. Okay, then only we can move and we can switch on the fan. Okay, so this is the basic process. So it's like that. Here also we need some sensing part and some processing part and then actuating part. Okay, so sensing part is the sensors, and thinking part is our processors, and then actuating part is our actuators. Okay, so for this processing part, here we take a Raspberry Pi. Okay, so here we take a Raspberry Pi. So this is our main processor here. So I hope all of you have some basic knowledge about Raspberry Pi. Okay, so I will give a short introductions about Raspberry Pi. Raspberry Pi is one of the microprocessor. Okay, and its credit card size is CPU. It's a CPU. It's a central processing unit. So it's a computer. Okay, but the size of this CPU is a simple credit card size. Okay, so and it was created by the Raspberry Pi Foundation under the Cambridge University. Okay, and here the Raspberry Pi has a lot of versions, lot of generations. For example, it started from Raspberry Pi 0 and Raspberry Pi 0W and Raspberry Pi 1, Raspberry Pi 1A, 1B and 2, 2A, 2B model and 3, 3A, 3B model, and now we are in a Raspberry Pi 4 era. Okay, so for our sessions here I'm take a Raspberry Pi 3 model B. Okay, so this is the specifications about that. So the processing speed of Raspberry Pi 3 model B is a 1.4 gigahertz and it has a 1 GB inbuilt RAM and it has a 8 GB to 32 GB ROM. So we need to connect to the external ROM 8 GB to 32 GB. Okay, so this is the basic things about Raspberry Pi, and I will explain about the each and every components. Okay, so this is our Raspberry Pi board. The main processor of this board is a Broadcom BCM2835. So this is the main processor, and this Raspberry Pi is based on a ARM11 architecture. All of our mobile phone have a Snapdragon and MediaTek and some Helio processor and Samsung Exynos processor. So these all the processor are based on a ARM11 architecture. So like that, this Raspberry Pi is also based on a ARM11 architecture. Okay, so and we can call this processor as a BCM2835. BCM means it's a Broadcom. Okay, and it's a system on chip. Okay, okay, and then so this Raspberry Pi 3 model B has a 4 USB ports, and this all the USB ports are on a 2.0 version. Okay, so and all the versions or the generations of Raspberry Pi is only depends on the specifications. For example, if you take a Raspberry Pi 0 means there is no any Wi-Fi connections and there is no any USB ports, there is no any LAN connections. It has only the micro USB port, yes, so the micro USB port and micro HDMI port, so that's all. And it has some 40 number of GPIO pins, that's all. Okay, and if you move with the Raspberry Pi 2 means, so it has some USB ports, and Raspberry Pi 3 it has USB ports and it has a LAN port, it has a HDMI port and it has a audio jack. Okay, so that all the specifications all the generations of Raspberry Pi is only based on that specifications. Okay, so this is the Ethernet port, so we can connect to the LAN cable through this port, and so it has some inbuilt Wi-Fi connections and inbuilt Bluetooth connections. Okay, so we can easily connect this device with our internet. Okay, and then so this is the 3.5 mm audio jack, so so we can connect this for some audio output. And next, this is the HDMI port, is a video output port, high definition multimedia interface. Okay, so we can connect to the monitor, we can connect to the projector, we can connect any displaying device through this HDMI port. Okay, and then this is a 5 volt micro USB power supply, so we can connect to the 5 volt normal power supply to this Raspberry Pi. Okay, so and this part, so this is one of the bus connection, so it is used to connect to the Android display. If you want to connect any one of the display, Android display or some any one of the display means, so we can connect through this bus port, and as like here is also the same bus port. So and this bus port is using for camera connections, Pi camera connections. Okay, so if we want to connect to the Pi camera means we can connect through this port. Okay, so and then the back side of the Raspberry Pi, so we have one memory card slot, so this is our main hard disk. So we need to boot up the OS to this memory card, and we need to insert it to the Raspberry Pi, then only we can activate the Raspberry Pi. Okay, so the OS, the operating system of Raspberry Pi is a Raspbian JC. Raspbian JC is a official OS of Raspberry Pi, and it has some 30 number of 30 variety of OSs are there. Okay, and Raspbian JC is a official OS from raspberrypi.org. Okay, so and we can download this. It's a free and open source. If we want a OS operating system for this Raspberry Pi, we can easily download it from official website. Okay, so this is the graphics card, and then here this is the internet controller. Okay, so and then very important for part of this Raspberry Pi is a GPIO pins, general purpose input output, because I'm told is a Raspberry Pi is a one computer. Okay, so our as like our laptop, our normal personal computer, our desktop computer. Okay, but it has some GPIO connections. The other CPUs they don't have any GPIO connections for connecting external devices. Devices means if we want to connect our home appliances means, so we cannot connect it to the normal CPU, normal personal computers. Okay, but if you take a Raspberry Pi means we can use this as a computer as well as we can use this as a home appliances devices. Okay, so that's why I'm telling this is a very important part of Raspberry Pi. Okay, so it's very important. And then let's talk about the GPIO pins of Raspberry Pi. So it has a 40 number of pins. So see, so it has a 40 number of pins, and this is the first pin, and this is the second pin, so this is the third, and this is the fourth. So up to, and there is a 39 and there is a 40. Okay, so the pin description of Raspberry Pi. So it has a 40 number of pins, and in this 40 we have a four pins for power supply, and in this 4 we have a 3.3 volt pins, and as well as the 5 volt pin. Okay, so we have a 2 number of 3.3 volt pins and 2 number of 5 volt pins. Okay, so and we have a 8 number of ground supplies. Okay, so this all the black colors are mentioned as a ground supply pins, and remaining. Okay, so see, so 4 power supply pins plus 8 ground supply pins, and plus here we have a 2 separate pins for I2C communications. Okay, so I2C communications, so plus 2, so totally the 14 pin, and remaining 26. So in the 14 pin, this 14 pin for using for this separate process, and remaining all the 26 pins are using for the GPIO connections, general purpose input and output. So this is all the pins are the digital pins and bidirectional pins. So there is no any analog pins, that all the pins are digital pins. Okay, so and for this process we need some language, some programming language. So because we need to communicate with the machines, so machine knows only the some machine languages like zeros and ones, that the binary codes. So we need a one separate programming language for activating this Raspberry Pi and collecting the sensors data from environment and upload it to the clouds. So we need a one programming language. So here we take a programming language as a Python. Okay, so Python is our programming language here. Okay, so let's enter the Python. So I hope all of you have some detailed knowledge about Python programming. Okay, so I will give us some short introductions about Python programming for newcomers. Okay, so Python is a programming language, we all know about it. Okay, so and in a programming language we have two types, a low level programming language and high level programming language. Okay, so we are the humans, we know only the high level programming language, machines knows only the low level programming language. So we need to convert this normal high level programming language into the machine level programming language. So for this conversion process, definitely we need some translator. Okay, so and there is a two types of translators are available in the programming languages, and one is a compiler and another one is an interpreter. Okay, so and all of you are the MCA students, and I hope all of you have some knowledge about this programming language. Okay, so compiler means so it's run the whole program, and interpreter means it's run the program as a line by line. So this is a simple differentiations. Okay, and our Python program is a interpreter program. Okay, so and this one of the some when we compare with the normal compiler programs, programming languages, so it has some disadvantages, no? So but it's a survey, so it's taken from 2015. So in this survey 31% of programmers choosing this Python program only. So because we know about the Java and C and C++, so because that if there is no, without Java there is no any Android applications, Android mobiles. Okay, so but that Python programming is overtake the Java, so by some features. Okay, so what is the reason behind of that? So how that Python has that much of level? So the simple, so it has a more number of features when we compare with other programming languages. For example, if you take a syntax, so syntax means it's nothing, it's a grammar and structure and set of rules. Okay, so the grammar of programming language called as a syntax. Okay, so when we take an example with a C programming language, hash include is open tag and close tag. This is the header file inclusion method in C programming language. So in this single line we have a three number of syntax. Hash is one of the syntax and open tag close tag is one of the syntax. And if we include some header files, for example conio.h, that extension is one of the syntax. Okay, so in this single line we have a three number of syntax. But in Python programming, so the simple keyword input and file name. If it is a time is a file name means, so we can easily import this module file using by this command input time, that's all. Okay, so and next if you take up if conditions in a C programming, so if two greater than one, so there's a simple program for identifying the syntax. Okay, so open curly braces and print f 2 is high, and finally we have a semicolon and close curly braces. So in this two line we have a three number of syntax. So the open curly brace is one of the syntax, so it's very important syntax. And print f, that f is one of the syntax. And finally the semicolon is a one of syntax. Okay, but if we change this program into the Python language, so if 2 greater than 1, so it just print 2 is high, that's all. So see the different, so it have a once colon, there is no any colon. Okay, so and here we have a one curly braces, and instead of that we have a one indentation, this space. Okay, so this space mentioned as a block of codings. So here this curly braces mentioned the block of codings, and here that indentations means this spaces, so it's mentioned the block of codings. Okay, so this is a heading and this is the inside program. Okay, so if we want to write another one introductions like else, so then we need the separate indentation for this block of codings, print on is high. So this is the different, and it is a very important syntax in Python program, that indentation. Okay, so when we compare with the other programming language, this Python has a very simple syntax. So and next, automatic memory management. So for every programming language we need some memory space for save the data and save the instruction. Okay, so we need some memories. Okay, so in other programming languages we need to align the memory space for particular data, so using by the data type. So because so all the data has a have a some memory space, separate memory spaces. If you give a integer means that requires some memory space. If you give a strings or float means that also requires some memory spaces. So it's difference depends upon the data types. Okay, so we need to declare the data types in other programming languages. For example, int a is equal to 4. So here the 4 is an integer, but we need to denote that. Okay, so then only that machine can access the some space, some memory space for this integer. But in a Python programming language, there is no any need of integer. Okay, so data type, so it's automatically automatically identified the integer, and it's automatically assigned the memory space for that data. Okay, so that's why we called this automatic memory management. And next, in a character, for character we need to mention that that's a character. Here a is equal to the simple quotation of 4. Okay, it's automatically take as a character. And string, So, and general purpose means nothing, we can use this programming language for every domain. Okay, so that's called the general purpose. So because it has some lot of memory, lot of module files. Okay, so a lot of module files, so that's why we can use this Python program for every domain. Okay, so I denote the some number of example module files. So first one is a OpenCV is a computer vision. So we can identify the purpose of this OpenCV using by this logo. So because it has a red color and green color and blue color, so RGB. So RGB means it's a image, the basic primary colors. So we can use this module file for image processing. Okay, so OpenCV is a module file for image processing in Python. And next, Django. So if you take a Django, so this is the module file for creating a web applications. So we can use this Django module file for web applications and web developments. So and then Pygame, so it's like the name, so it's used to create the game development, it's used to develop the games. Okay, so and next, Maya is one of the module file for creating a 3D and animations. So these are the very few examples. So and there is a lot of module files are available in Python. Okay, so and let's see the one by one applications, the real-time applications. And so what are the companies are using this Python programming in their own applications? Okay, so first see the application. So this is the one Android applications. So it's capture the object and it will gives us some details about that object. So definitely it's a image processing concept. Okay, so it was created by OpenCV and it's from Google. One second. Okay, so it's a Google Lens, it's 100 applications that was created by OpenCV. So and next, so this graphics, these animations is done by Maya module file and it's from Maguda Visual Effects. Okay, so and then the Quora application, so it was developed by Django and from Quora. So and not only that, so most of the companies, the famous companies, top companies are using this Python programming for their own developments. So even NASA using this Python programming for their data encryption and decryption method, and Google and YouTube and Netflix for the recommendation system. So and Dropbox. So and the list goes on. So there's a lot of top companies are using this Python programming for their own development. Okay. So simple. So and so we learn about some details of Raspberry Pi and Python programming. So now we are going to interface this with our hardware. Okay, okay, so here I connect this Raspberry Pi, so using by the VNC Viewer. Okay, so VNC Viewer means it's nothing, it's like a team viewer or any desk applications, desktop, remote desktop. Okay, so we can access this Raspberry Pi using by our network. Okay, so because it's one of the computer and we have a one computer, one PC, so we can't interface the both computers, so that's why we connect the Raspberry Pi through the VNC. Okay, so and so there's a Raspberry GC OS, and so it's a start button, as like our Windows start key. So it's a programming, so these are the inbuilt programming in that OS. So Python 2 and Python 3 and node rate. So and this is the internet, so web browsers and games and accessories. So these all the games are developed by Python programming, and next accessories and help and preference and some power. Okay, so it's Chromium web browser, and this is a file manager, Okay, so we can save our data. And so this is the terminal. So because it's a Linux based OS, if you want to if you want to access the admin locations, we need some commands, some Linux commands. Okay, so for security purpose they are updating their own OS using by the Linux. Okay, so it's a Linux terminal, and here the VNC, and it has a Bluetooth connections and Wi-Fi connections and these things. Okay, so and then I open the camera. I already connect this. Okay, see so here the Raspberry Pi, I connect the Raspberry Pi. Okay, so and this is the ADC. So because here I'm uh, connect to some gas sensor. Okay, so to gas sensor, these gas sensors are the analog sensors. Okay, so I'm already told there is no any analog pins, separate analog pins, that all the GPIO pins of Raspberry Pi is a digital pins. Okay, so but here this gas sensor as the analog sensor. So if we want to connect any analog sensors means so we need one separate module. So we need to convert these analog signals into the digital format, then only we can read the data from analog sensors. So that's why here we using that module ADC, analog to digital converter. Okay, so this is the IC MCP3008 IC. Okay, so here I'm connect this two sensors to the ADC module, and after converting to the digital format, so we can get this data from this ADC, and I connect it to the Raspberry Pi board. Okay, so let's see the program. So how to get a data from this gas sensors. Okay, so and before that I will give us some warm up for Python programming language. Okay, so here I'm take a Python 2 idle, and I open a new file. Okay, so the the Python is a very simple program when we compare with other programming languages, no? So I just give a one program for analyzing the syntax of that. So so I'm creating a variable is equal to, first I'm going to get a input from user. So input, so this is for analyzing the syntax, that's all. Okay, so enter the value, enter the a value. Okay, so enter the a value, and I give a column. So such like, so I get a data for b. Okay, so simple, the if condition. Okay, so if so a greater than b. Okay, and definitely here we need a one colon. Okay, so because it's a heading, for heading we need a one colon. If you give a colon and click a enter button, so it will automatically take this indentation. Okay, so because indentation is very must in Python programming. Okay, so I'm just to give a print a is high. And instead of LCF, so here we using a LF. So b greater than a means so b is high. Okay, so and the simple else. Both are same, that's all. So I just run the code, and before that we need to save this code. Okay, so enter the value, I'm give a 4, and enter the b value and give a 6, b is high. So it's for some syntax analyzing, that's all. Okay, so and next, so let's move to the sensor part. Okay, so this is a program for getting a sensor values. Okay, so from MCP3008, so as I'm told already, so if we want to include any one of the module files or header files means we need to give a import keyword. Okay, so using by this import keyword, here I'm called the MCP3008 module file. Okay, so from MCP 3008, here I'm just import the MCP 3008, and next import time. So this time is for time purpose. Okay, so and next ADC is equal to MCP 3008. So I set all the functions of this MCP 3008 into the ADC. Okay, so I'll show the program of MCP 3008 module file. So this is the program. So these all the things are some comments. Okay, so that's no need at all. Okay, so from SpyDev import SpyDev. So using by this SpyDev module file. So SpyDev means it's a serial peripheral interface. So because we connect this ADC module file into the Raspberry Pi using by this communications, using by this protocol communication, serial peripheral interface. So this is a module file for that protocol. So and here I'm create a class MCP 3008, and this is the initialization, and next open of self. So it's a open means, so we need to open the SPI port. Okay, serial peripheral interface port, then only we can access that. Okay, so if you have any questions instead of this process, sir, in between this class, so just ask ask your questions in a chat box, so I will explain it in at end of the session. Okay, so we have the separate part 2 for the doubt clarification system. Okay, so and here I'm read the data. So read self and channels. Here we need to set the channel. So because I show the ADC. Okay, so this is ADC means, so there are 8 pins in the left side. Okay, and 8 pins on the right side. Okay, so and these are the channels. So we can connect those 8 number of sensors to these 8 pins. Okay, so this is the 0th channel, and this is the 7th channel, and this is for power supply, and this is for ground supply, and this is for ground supply, and so here 2 3 4. So this pins for the communications, it's a protocol pins. Okay, so we need to connect these 4 pins into the Raspberry Pi. Okay, so this channel, so here I'm connect the on gas sensor to the channel 0, and here I'm connect to the gas sensor to the channel 1. Okay, so this is the gas sensor 1, and this is the gas sensor 2, and this is the channel 0 and channel 1. I'll clear all the doubts at the end of the session. Okay, okay, so we need to set the 0. 0 is our channel, so initially it set the channel as a 0, and we can change that. Okay, so ADC, so this is the process for converting the analog signals into the digital signals. So because SP and XFER2 so this is a multiplexer and demultiplexer concept, so that we are learning in our science some school days. Okay, so multiplexer and demultiplexer concept. So it has a 8 channels, so we need to convert these all the channels output into the 4 channel. So that's why we're using this method. And next, data is equal to ADC of 1. So here we split it into the 2 part, ADC 1 and ADC 2. So because so it gives us some 11 bits of data. Okay, so 11 bits of data, but we need only these 8 bits. Okay, so these are unnecessary. But if we can't directly remove these 3 data, so if you remove this 3 data directly, means it will affect this 8-bit data. Okay, so using by the multiplexer concept, we need to add these 3 data into here. Okay, so using by the AND operation. Okay, so that's why here we're using the AND operations with the 3, so and the 8 channels. So that's why we split it into the ADC1 and ADC2, and the final data is stored into the data. Okay, so this read function is return the data as the output. Okay, so we close that. So in our main program, we call this module file, we call this program as a module file. Okay, so using by this import command, import MCP 3008, and instead of that, so we call the read function. Okay, so gas 1 is equal to ADC dot read of 0. So because this ADC, so it will have all the functions of MCP 3008. So and from this all the functions. Here we separately read the call the read function. So 0th channels, here I'm connect the gas sensor 1 into the 0th channel, that first pin, and next I connect the another gas sensor into the second channel, that is a channel 1. Okay, so using by these commands adc dot read of 1. So and this all the data are stored into the gas 1 and to the and gas 2. So and just I print gas 1 as a gas value. Okay, so and using by this time module file I'm given some time delay. Okay, so and inside it's this parameter is mentioned as seconds. So if you give a 1 means it's take a 1 seconds. Okay, so that gas values are printing for every 1 seconds. So and I already connect to the sensors to the Raspberry Pi with the help of ADC. Okay, so and I just mentioned the okay, 1 second. So I will explain about the circuit diagram. Okay, so I'm opening fritzing software. So and I take a Raspberry Pi 3. Okay, so the Raspberry Pi 3 and next MCP 3008. Okay, so we can, so this is the 12 bit controller. We can use this IC, otherwise we can use a MCP 3008. Okay, so if you have taken 3208, this is a 12-bit controller IC, and if it is a 3008 means is a 10-bit IC. Okay, so and next take one gas sensor. Okay, so I am take this gas sensor. Okay, so see this is the channel 0. So and this is the ground pin and data pin, digital pin, and this is the analog pin. So we need to connect this analog pin into the channel 0. Okay, so next this is the VCC. So I connect it to the direct Raspberry Pi VCC, that's the 5 volt. And next this is the ground supply. So I connect this ground supply into the Raspberry Pi's ground supply. Okay, so I mentioned the ground supply as a black, so and power supply as a red, and this is the blue color data. Okay, so and if you want to connect the another sensors means the same method. So you need to connect the analog pins into the channel 1, that second pin. Okay, so and next okay, so this two pins are for power supply and this pin for ground supply, and this is the data pin. So I connect this clock pin into this clock pin, Raspberry Pi clock pin. So there is GPIO 11 and this pin GPIO 9 and this pin GPIO 10 and that final pin is GPIO 8. Okay, so these are all the data pins. So simple. So this is the circuit diagram. So I already connect this. Okay, so next, so we are going to run the program for getting a sensors data. So this is the gas sensor, so we need to analyze the gas, we need to find out the gas. And here I'm given some lines for split the data. Okay, so it's print the data. So 18 gas sensor 1, it gives us a 14, and gas sensor 2, it gives us a 18. Okay, so and I just add the some gases to the sensor. Okay, so here I'm using a sanitizer for the gas purpose. So I just give a sanitizer gas. So see the gas values. So this value was increasing. So gas 2 value was increasing. So normally it gives us a okay. So at the initial stage, it gives us only the 18. Okay, so while we give some gases to that gas sensor, so it will gives 21 and 70 and 53. So it will increase the data. So these are all the analog data. So using by this data, so we can actuate any one of the actuators. Okay, so now we get a sensors data from the environment. So we collect the sensors data. Okay, so after getting a data, so we need to upload this data into the cloud using by Internet of Things. Okay, so first initially, so I want to share this data using by the MQTT protocol. Okay, so data communications means it's simple. So share the data from one place to another place. That's I'm told already. So sensors, it's collecting the data from sensors and it will send it to the processor, and using by this internet technology and some cloud platform, so we can send this data into the cloud platform. Okay, so processor into the cloud. Okay, so data communications MQTT. So this is the one of protocol. MQTT is one of the protocol. So that's called message queuing telemetry transport. Okay, so we can send this data to MQTT protocol. Okay, so what are the protocols means, that's I may explain here. The simple, so basically this for this MQTT we need a two part. Okay, so first one is a broker and another one is a client. Okay, so broker and client. So first, so this is the temperature sensors data. So as well as the processor, this processor send the data, send this 70 degree Fahrenheit into the MQTT broker. So we need to send our sensors data into the broker. Okay, so and after that, so this laptop is one of the client, and this mobile device is one of the client. So we have the clients, we need to subscribe this MQTT broker. Okay, we need to subscribe that, then only we can get the data. Okay, so we need to subscribe that protocol. Okay, this mobile device also need to subscribe the protocol. Okay, so then only, so we can get the data of this temperature sensor. So that's why we called this as a protocol. Okay, so here we are going to do that method. Okay, so I just program for that. Okay, so this is the program. Import paho.mqtt.client as paho. So this paho MQTT, so this is the module file for MQTT protocol. Okay, so and from this module file I justly change this module file's name as a paho. So because it has a some the Python is in a cache sensitive, no? And it has some lot of characters, so that's why I give us some alias name as a simple name. Okay, paho.mqtt.client as paho. So we can use this total module file using by this name paho. So next the same process from MCP 3008 import MCP, and next here I'm create the one function using by this def keyword. So I give a name as a unpublish. Okay, so and inside of that I set a three parameters. First one is a client, and next user data, and then meet. Okay, So and inside of that I just print the mid value, that's all. Okay, so I just print the mid value. So this is the one function, so because we using the def. Okay, so next client, here I'm create one client variable is equal to payho.client. From this payho module file I call the client function, and all these functions are stored into the client variable. Okay, and from this client here I'm called the connect function. Okay, using by these connect functions here I'm passed two arguments. So this is our name, so this is our broker name. Okay, and this is the port address. Okay, so 1883, so this is our port address. So this is our port name and this is our port address. So using by this name and this address we need to subscribe this protocol. Okay, so subscribe this broker, and after that client dot loop start. So here I'm called the loop start. So this loop start is using to continuously run this program. Okay, so run this Payhook client. Okay, so ADC is equal to MCP 3008. I store this as well as the previous program. Okay, so gas 1 is equal to ADC dot read of 0 and gas 2 is equal to ADC dot read of 1, and next print gas 1 gas 1. So I just print that, and after that I publish this data, gas 1 data and gas 2 data, into the some particular broker. Okay, so using by this name. Okay, so sensor slash temp and sensor slash, so here I'm change this into the gas 1 and this is gas 2. Okay, and I upload this into the string of gas 1 and gas 2. So using by this publish, so now the broker it's need to publish the data to the subscribers, to the clients. Okay, so using by this publish function. Okay, so I publish the data like this. Okay, so this is our name, so this is the sensor name, so this is the sensor name and this is sensor data. Okay, so we can see the sensors data using by this name. Okay, so this is the name and this is the broker name. Okay, so and in my mobile phone we want to download on applications, that is my MQTT. So I show that. Should I show my mobile screen here? Okay, I share my mobile screen. Okay, and instead of that I open my MQTT. So this is my application for MQTT, so my MQTT. So I now open my MQTT dashboard. Okay, so in here, so we need to set we need to subscribe the channel, no? Okay, so settings, so and here it requires the broker URL. Okay, so our broker URL is a, okay, so broker dot MQTT dashboard, broker dot MQTT dashboard .com. Okay, so and 1883, 1883. So I give that and I save this channel. Okay, so I successfully connect, so it will connect. Okay, so and next we need to subscribe the channel. So I'm give a name for that. So sensor slash gas 1. Okay, so because that is our name, sensor slash gas 1. So I add that, and the same sensor slash gas 2. I add that. Okay, so simple. So we finish that, and next I open my dashboard here. I guess there is no any notifications, and I just run the program. So this is my mobile screen, and this is a Raspberry Pi. You see, so 1 second. You see, so in a dashboard, so we see the data. So sensor gas 1 values and gas 2 value. Gas 1 value is mentioned as a orange color, and gas 2 value is mentioned as a blue color. Okay, so we successfully update the data into the MQTT protocol, and we can see this data using our mobile. Okay, so after that, the next cloud. So we are in need of updating this data into the cloud. So I just close it. So finish. So next, this is the program for uploading the data into the cloud. Okay, so on before that we need a on Thinkspeak cloud account. So I just give a Thinkspeak. Okay, so Thinkspeak, I open the Thinkspeak, and okay, okay, so I open my Thinkspeak cloud account here. So and I create a new channel. Okay, so in create a new channel, I set the name for this channel. So sensors monitoring. Okay, so and field 1 is a gas 1, and field 2 I enable the gas 2. So this for gas 2. So simple, I successfully created. So I save the channel, and for uploading the data to this channel we need a API keys. API keys means it's application programmable interface key, so we need that. So here they provided two types of keys, write API key and read API key. If you want to upload the data to the cloud means, so we need a write API key. If you want to read the data from the cloud means, so we need a read API keys. So now we are going to upload the data to the cloud, so that's why we need to copy this write API key. So I just copy it. Okay, so and here I'm change this. So see, so HTTP lib, this is the next new module file. So for accessing the URL link, okay, and this URL lib and the HTTP lib is for that process. And here I'm just mention the key as our write API key. Give me a second. So we need to write that. Okay. So FADYX and VST 5MB is it 27U1. Okay, so that's all. Okay, so and next, so gas 1 as well as the same process as the earlier program. Gas 1, so ADC.read of, okay, so that's all. And next parameters, so parameters equal to URL lib. So and here I'm given 0.5, so 0.5 seconds. So parameters is equal to URL lib. So using by this URL lib module file, here I'm encode the URL. Okay, so encode the URL. So in this field 1, we need to upload the gas 1 value. In this field 2, we need to upload the gas 2 value using by this key. So this is the dictionary format, and we need to encode this URL. Okay, so and next header. So this is a header program for reaching that website. Okay, reaching that web page using by this name, port name and the port address. Okay, so and next connection dot request of post and update. Here we are going to update the values, and what are the data space is a params data. So that params data are called here. So and headers and response equal to connection dot get response. So response means so what are the status of the connections. Okay, so health of the connections, data is equal to response dot read off. And finally we print if it was successfully uploaded to the cloud means it's printed that done, so otherwise it's print connection failed. Okay, so that's why we're using the try and exception. So exception means if there is any error or any interrupt in this try conditions, so it will automatically move into the except. So that's why we get a connection failed. So this data is uploaded for every 3 seconds. Okay, so let's check this. So I run this code. Okay, so we will check the Thinkspeak cloud. So we get a data. So it's a gas 1 data, so it's uploaded into 115. So the value of that data, so 115, and the next that time, so that particular time that the gas value is a 115, so that was uploaded. And next, so in that particular time, so the gas value is reduced 111. Okay, so and gas 2 value is continuously gives the 19. And if I am add the some gases to the sensors means, so it's need to increase it. Okay, so it's increased. Okay, and we can see this we can monitor these gas sensors values using by this Thinkspeak cloud from everywhere. Okay, so it will be increased. Okay, so that's all. So here we successfully upload our data, our sensors data into the MQTT protocol and the Thinkspeak cloud. Okay, so this is the Internet of Things. So because here we simply connect our room gas value into the internet. Okay, so that's why we called this is the Internet of Things. So we can connect the normal things, the basic things into the network. Okay, so that's the Internet of Things. Okay guys, so that's also in our today's session. So we are saw the introductions about Internet of Things, and introductions about the Raspberry Pi, and introductions about Python programming, and how to interface the sensors, analog sensors to the Raspberry Pi using by ADC, and how to upload this data into the MQTT protocol and the Thinkspeak cloud. Okay, so these are our today's sessions. If you have any questions related to the topic, so kindly mention it in a chat box. I will give a explanation. Okay, so I have on some questions from viewers. Okay, why Python 2 and Python and not 3? So there's no any difference between Python 2 and Python. There are some basic difference. So because Python 2 has a lot of module files when we compare with the Python 3, and Python 3 generations is now under in the constructions. Okay, so that's not fulfilled at all. So that's why we're using Python 2, and Python 2 is very useful for identify the concept, identify the syntaxes. Okay, so and it's very important, very easy for beginners. Okay, so because the official Python community is officially announced the statement of so we will remove the Python 2 from January 1 2020, but till now they are not removing the Python 2. So because that requirement is valid, the requirement of Python 2 is valid, so that's why they are not removing the Python 2 until now after the official confirmations. Okay, so that is very important. So we can use the Python 3 also, that's not a problem, that's not big issue. So next, yeah, again 3 is the latest version. Yeah, yes, 3 is the latest version. And Aditya Aryan, sorry, elif means it's a simple. In our other programming language we are using a else if conditions not satisfied means then we check other conditions, that's called else if. Okay, so in other programming languages, but now in a Python programming language we conquered that else and if as a elif. Okay, we simplify the meaning, we simplify the two words, that's all. Sujit Sundaration, how to learn these protocols and its programming. So there is a lot of internship programs and some lot of materials are available in online. Okay, so if you want to if you want to learn by yourself means you can read the topics in websites. So otherwise if you want any guidance means you can anytime um, uh, reach our NoviTech office. Okay, so we will learn you the protocols oriented and programming oriented internships like that. Okay, so and there is a lot of some tutorials available in a websites also. Okay guys, so I hope all of you enjoyed this session, all of you get some knowledges about Internet of Things and how to upload the data to the clouds. Okay, if you like this video kindly click a like button, so and share this video with your friends and colleagues. Okay, so and so we need a some feedback from everyone, so just to mention your comments in a comment section. So after uploading the video, so you can get a comment sections, you can you need to post your feedback about this session so into the comment sections. Okay, and we will see this share the review link of our Google review link, so and all of you give your comments and give your ratings in our Google review. Okay, so we already shared this link in a chat box. And once again, I would like to say the thanks to the management of Hindustan College of Arts and Science and the Department of BCA and the coordinators and the conveners, so and beloved students. So thank you all.